All right, well, welcome everyone. My name is Paulmichael Blasucci.
You okay?
And did we already lose the camera? Or should I
No, let's keep it's going.
All right. And what we're going to go over is a library that I've written recently called fs-zmq. And the library is just a vehicle. The thing I really want to go over is this concept of working at the right level of abstraction. Because software is challenging, and part of the challenge, I think, is that you don't just have one problem to solve. You get a bunch of different problems to solve, but a lot of tools, a lot of languages, they give you one way of doing things, and what winds up happening is you wind up shoehorning your problem into the way that that language solves things, instead of really finding the right solution for the given problem. And one of the things I love about F# so much is that it gives you a lot of different tools. It gives you a lot of different, sometimes seemingly completely unrelated feature sets that really lets you go to the right level of abstraction to solve a given problem. And that's what we're going to look at today in this walkthrough. Just a little background on the actual library itself. It's a wrapper in F# over a native library called nyc-fsharp. Just a little background on that just to give us some context. nyc-fsharp is meant to be a low-ceremony distributed messaging library. It gives you some abstraction over some various protocols like TCP, pipes. It gives you some highly optimized byte transfer on the wire, and then it gives you, one of the things I like about it, it gives you bindings to many different languages, so you really just plug in the bits that are part of your application. You know, the messaging coding, the actual business logic, the raw data. And it gives you a few key concepts, and just so you're aware of these as you see them in the code, though this is really not meant to be about nyc, what you wind up building is you wind up building a network of sockets. Any node in your network will be a context that collects several different sockets, and each of these sockets pass messages, which are just a small abstraction over a series of bytes, and then pass them in well-defined ways, what we call message exchange patterns or socket rules. Things like publish, subscribe, or request reply. That's just some common message exchange patterns. And then you build code on top of that. So the first example I wanted to show you, and I want to apologize in advance if some of these examples don't work, because I am having some network connectivity issues, so we will hopefully still get a few of them to work. The first thing we want to look at is, this is just by way of example, we just want to look at a basic group chat server. Oops. Typo. And one of the first things I want to demonstrate about working at different levels of abstraction, it's not always necessary to go through the headache of building an entire project just to get something up and running. For this group chat, I put it together in about a half hour. All it is two F# scripts that I can run at the command line that will, if I get through the 85 security warnings, will allow us to do a basic chat server with very, very little effort. You can see I'm basically just invoking the F# interactive from the command line, which is basically giving me a poor man's message pump for doing GUI work. And I've got my server running in the background. There's one chat client. But right now it's just one chat client. That's kind of boring. Let's add another one. And again, because we're using F# interactive here, we can be a little quick and dirty. We can actually load this up directly in Visual Studio just by highlighting the whole thing, which is only 60 lines of code or so, and sending it to the interactive environment. And now, didn't lose focus, but now we have two chat windows. And we can see quite simply. Messages going back and forth, and it's very primitive, and this is not to wow anyone with the amazing things I've coded. The cool takeaway is that by combining some of the features of F# along with this third-party library, you've got a basic group chat server in 20 lines of F#, where I didn't have to create a project, I didn't have to spend a lot of time messing about with referencing things and configuring things. Just wrote some code and it runs. And the client, which as we can see is a basic, WinForms client, nothing fancy, but it's slightly longer. It's about 65 lines of F-sharp code. But if you go and comb through here, there are 4 lines. I mean, the overwhelming majority of it is just getting the window GUI stuff set up. And if anyone's interested, one of the nice things that's interesting is you've got, your client that's sitting there waiting to deal with user input, but it's meant to be getting messages in a group chat, and we can accomplish that very quickly and easily in F-sharp by simply using F-sharp's async functionality to set up a little background loop that just sits there and listens and pumps messages right into the GUI. One of the very, very interesting thing about this is you'll notice I'm not doing any special locking or marshalling to get the messages back onto the GUI thread. And the way that happens is a combination of the way the F-sharp async works, combined with the fact that I'm able to use something called a type extension, which is conceptually winds up working out similar to static code, hence there's no need to deal with thread marshalling to get you back onto the GUI. What's nice about the type extension is when I'm actually, I've basically gone in and done the equivalent of an extension method, but you can extend that to work at any level, extension properties, so on and so forth.
What's just a vertical pipe and a greater than single pipe?
Good question. That is piping. That is taking, for instance here, we're taking this context variable that we find here, and we're passing it to this request function. It's not unlike piping output from one file process to input to another process on the command line. It's a similar concept, except it's happening in memory with functions and data. So that's just a basic example to get things going. I'm going to skip my second example because it was actually a parallel task distribution sample, but because I'm having internet problems, I was actually going to have, because I'm actually running, I don't know if you guys can tell from here, but I'm actually running Windows 7 inside of a virtual environment inside of a Mac, and I actually was going to be having client on the Mac, client on the Windows machine talking to one another, to prove the point that ZMQ as a messaging library is not .NET easy. You're not tied into very simple, specific things. You can be pretty flexible with it. But unfortunately, the internet connectivity gods are not with us. So we'll move right on to looking at the basic project structure. And again, the structure of the project is not that important. What is important is F-sharp puts the F-sharp compiler requires that the inputs that are given be ordered. What this means is the order you arrange your files and your code in your project becomes significant to getting things to compile. Now, for a lot of people, that's a problem. That's the thing that people dislike. But one of the things that I consider a benefit is this really gives a newcomer or somebody who is not familiar with what you're doing a good place to start exploring your code. They simply go to the bottom of the tree and look at what's down there. And in the bottom of almost all of my F-sharp projects, there'll be 1 or 2 script files where I'm doing my intermediate incremental exploratory testing. You can then just work your way up through the files, and you can start to see in the middle of my file trees are just about always where I've got my proper API, the things the rest of the world's going to see, where the meat of my code lives, and then usually up near the top of my trees there'll be a handful of files that are some basic housekeeping stuff. In this case, we've got some native interop code, and that's about it. It's some memory management code. And we'll see some of that in a minute, because one of the other nice things about F-sharp, about providing multiple tools, is yes, it's functional, but we can also interop with native code. We have object-oriented code for memory management. We'll get to all that in a minute, but we're actually going to go right up the stack tree, right up the file tree backwards, and go through things. The first thing we're going to see is that inside of F-sharp Interactive, which I already showed in that first demo, you've got the ability to create quick and dirty applications without actually having to spend a lot of time with boilerplate, with setting up projects, and got to make sure my paths are correct, and yada yada. You can also do some incremental work inside of Visual Studio, which that I can show you a quick sample of. If I come over here to the actual project, you'll see I'm not lying. There's my actual Scratch file. One of the great things that lets you do is you can load up external libraries, and you can load up the individual. Why is it not getting Visual Studio's been on the story, right? And you can load up the individual source code in your project. So For example, native FS is a file that's actually in my project. I could load it up and interactively explore that file. What we're going to look at is, again, similar to the chat demo, you can combine this interactive environment to rapidly prototype things and get things going in a very quick and dirty fashion. So declare a couple of functions, and we'll go back through these in a little more detail in a minute. I just want to select it all and then move it all in. And you can see this is very much a scratchpad format with notes in here. And again, that's another way of dealing with a problem, of tackling problems. One of the problems you frequently face is you don't necessarily get the answer to everything the first shot, so things need to be incremental. One of the things we can do now with this is we can do not the most thrilling example ever, but hey, we've just loaded up some arbitrary code. And the important thing to note here is, unlike the other examples where I was loading in DLLs that I've already compiled and testing them, here what I've actually done to test that is I've actually loaded in individual F-sharp files, and F-sharp Interactive is actually compiling them on the fly for me, giving me a chance to work and test with them. And this file can get a little hairy because, like I said, it's a scratch file. But you can see it's, again, giving me the ability to do a lot of different things in a very, very flexible context. So back to our slides. Yeah, we saw that already. Moving up the chain now, what does actual code look like? All of this talk about interactive and quick and dirty is great, but what are some of the real things that F-sharp gives us? Well, one of the tools it gives you is a functional programming language, among other things. It gives you a whole raft of functional programming features, and I like to, a lot of times what I like to do is I like to use these functional programming features to keep simplify development of what we call in the small, meaning things at the immediate level of individual instructions of what you're working on, not the medium, which would be the various components in your larger architecture, or the large, which is getting things out to the wider world and managing users and so on and so forth. And some of the tools that we have from the functional programming world that we can use are things like partial application, function composition, higher order functions, and pattern matching. And at a slightly higher level, you have things like custom operators, and we'll look at things like discriminated unions and active patterns. Those let you go one step further and take small code and aggregate it to slightly more sophisticated, larger code. So we'll take an example. We'll look at an example of some of those right now. One of the first things I'm going to show you is this notion of pattern matching, where we'll come back to that. We'll start with the notion of discriminated unions. Effectively, a discriminated union gives you a very, very easy way to declaratively model some data. In this case, we have an object that represents a polling sequence, or one trip through a polling process to poll for messages. But what's interesting about this is you compare it with pattern matching, and what that lets me do is that lets me extract the data out of the construct as I'm using it, as opposed to having to define lots of get statements and set statements and property accessors to pull things out incrementally. I realize this might be a little off, but we're going to go look at a few other things. Another instance of discriminated unions making things simpler is very often one of the problems you'll find is that you have data that is related but is structurally different. And traditionally, in a lot of languages, you're stuck with doing things like structures or doing complex object hierarchies. One of the nice things you can do with discriminated unions is you can very concisely take disparate data that is related but has different structures and glue them together. For example, here we have this type message, which is a discriminated union describing a message. A message can either be data which is some collection of bytes, or it can be a command, which is quit. Now, if you're going to do this in, for example, C#, what you would wind up with is a small but non-trivial 3 or 4 class hierarchy. So this is another example of working to a certain level of abstraction in a concise manner. Getting back to the functional way of looking at things, we have this concept of higher order functions, which is also a very simple idea. You take a function, and you extract out the common parts of it, and then you provide another function to do the specific parts of it, which you see very often in C# when you're working with link and the enumerable extension methods. And you have something very similar in F# that is very easy to use, where I basically got the iter command on the C module, which takes a function and applies it repeatedly to a number of items. So this again lets me simplify my code in small. Instead of a large complicated while loop, I've effectively got a small abstracted higher order function to do the same thing. And what this is going to do is this actually, when you're doing in the context of 0 and Q, when you're subscribing to messages, they have a topic that you can filter on, and all this is doing is looping over a series of topics and filtering them. So, but lest we talk too much about purely functional programming and the things that it provides, we also have the larger .NET ecosystem to consider, and we have to deal with interacting with other CLR languages, and that can sometimes be awkward, but F# gives you a lot of tools to smooth that over. And there are some aspects to this. One is extension methods, which anyone who's worked with C# or VB.NET in recent years is familiar with. They translate seamlessly. You can turn most module functions in F# into an extension method simply with an attribute. Another thing that's often overlooked is this concept of custom compiled names, which is a way of saying, I'm going to call this one thing in F# because it makes sense for the mode I'm working in, but I want the outside world to see this a little differently so it's a little easier for them to understand. And just an example of that. There we are. You can see here I've got a method that, for one reason or another, I wanted it to be short and sweet and readable in F#, so I'm calling it get. But via the compiled name attribute, I can very easily say, when we look at this in other languages, in F#, in C# and VB.NET, we want it to say get option because it's more descriptive, it makes more sense in that context. And you can also see here what I was talking about how simply tacking on an attribute, and now I've got an extension method that looks and feels and reads and behaves.
What's the little tick T? Is that a generic?
Yes, that's just a generic annotation.
Don't you need the generic also in get option? Calling from C#.
The F# compiler is very, very good about types and about type inferencing, and that's one other thing that you'll
It knows it.
that there's not as many type definitions and declarations throughout the F# code, because the compiler can infer an awful lot of that, and this is another example of that. It can infer that, and truthfully, compiled names are very simple, it's just a very simple string substitution that's happening in the compile process, so really wouldn't require it anyway. But you're not changing the type of anything, you're just giving it a different moniker. But yeah, that's one of the other things. And there's the extension method. And one other thing that I want to just point out for anyone who has been playing around with C# and F# a little bit, you may find that F# has first-class functions which seem a lot like delegates, but there's some stylistic and syntactic inconsistencies between the two. And one of the things I want to point out, just so people can see it, is it is very, very, very simple to take in a delegate. Here we've got a delegate of func of 2 inputs and 1 output. And it's very easily to turn that into an F# first-class function that can be used seamlessly in F#. So that's not something that if anyone's run into should really fuss them. And I'm sorry if I'm rushing a little bit, but I wanted to try to give Steve plenty of time for his presentation. The last bit we want to look at is we have to interact with native code sometimes, and truthfully, despite any other models, I think object-oriented code, as it's implemented in the .NET ecosystem, provides some very good models for dealing with native code. Now, we also have p-invoke, the full range of p-invoke available in F#. I'm not really going to go over that now in this abbreviated presentation. Suffice it to say, it is one-for-one feature identical with C#'s p-invoke implementation. So, but what I want to focus on is, OO code does become useful to us, and it's not like, well, function is function that. Object-oriented code, it can be very useful for resource management. I mean, that was the primary reason why it was added to C++ when C++ was first designed, and we use it here as well. In particular, we combine the notion of using a class to manage the life cycle of our expensive native handle with the notion of the iDisposable interface to give us some automatic resource cleanup. For instance, here we have a message class which wraps a series of bytes and has to do some data allocation in native memory, has to do some marshalling, and effectively, if I just collapse some of this down for you so you can get a better sense of the full class, you can see it's a very small class. I mean, that's the entire class right there. And all it's doing is providing a nice clean wrapper on top of initializing some native memory and interacting with that memory. And it implements the iDisposable interface, which means we can use, and you may have noticed before in some of my Scratch code, this use keyword. This is effectively, if you've worked with using in C# or VB.NET, this does the same thing. This effectively says, we're creating an instance of a class that implements iDisposable, and at the end of our scope, we're going to call dispose on it to properly clean up resources.
Where is the end of the scope? I mean, in C# using there's a specific...
A good question. In this case, F# is white space sensitive, so indentation will determine the end of the scope. So for example, you can see here, this let function, this is one whole scope. So what will happen is the disposing on those uses will get declared when we come out of the scope of this function. So that's something that I probably should have mentioned. F# does use white space to indicate scope. And one other sort of interesting thing, I want to go back to what we were just looking at. One bit of code that's a little more complicated, but I find really, really cool and interesting, is these orthogonal feature sets may seem like they have very little to do with one another, but you can blend them together quite easily. For example, here I have a class, a standard .NET, C#, CLR class. It has a constructor. In my constructor, I'm mixing, pattern matching, functional concept. I'm mixing calls to native code by a P invoke, very procedural concept, and I'm mixing your basic object management of doing a constructor and initializing some private fields on a class. So you can see it's a really interesting example of taking the different paradigms, each working with a different problem, working with that problem at the appropriate level for that problem, and combining them together into a more cohesive whole. And at this point, I think I may have run a little ahead of myself. I think we've got about 10 minutes left on my clock. So let's see what else is in the slide deck. We're talking about resource management. There we are, the bottom line. And this one sort of, I hate to read from the slide directly, but I thought this just really summed up my whole thing I would like everyone to take away from this. By blending orthogonal features across multiple paradigms with familiar libraries and powerful extension points, F# lets developers work at the right level of abstraction for a given problem. And that's the idea is you've got lots of different features, functional, object-oriented, procedural, interoperating with native code. They can all stand independently, they can all mesh together. You have a whole host of libraries that you know from the CLR, from .NET. You have some great convenience tools in F# Interactive and the whole notion of doing scripted development. You've got the full support of Visual Studio and the rest of the wider ecosystem. And the truth is, at the end of the day, you don't have to spend a lot of time with boilerplate and with forcing, okay, well, I have to make everything an object, and I have to deal with this dependency chain, so I have to use an IOC. And you can look at the actual problem on its own merits in its own domain and pick the level of abstraction that lets you best master it into the solution you're trying to build. And last slide, for more information, these are some links if anyone wants them about where to get more information about F#, about nyc-fsharp. Last link is a shameless plug for my blog that nobody reads. And at this point, I think I want to open up to any more detailed Q&A anyone might have.
So you talked about a lot of good stuff in F#. I'm wondering what's your experience with some weaker points in F# or
Weaker points?
Yeah, or some flaws as opposed to other.
Okay, flaws as opposed to strengths in F#. That's actually a good one. I'm trying to think. Well, I hate to say flaws. I mean, one of the things that I found this is not the first version of this library, obviously, that I've written. The first version was actually compiled pre-Service Pack 1, and there were some compiler bugs and oversights, so that's something that would be considered a flaw. But as far as linguistically, as far as the syntax of the language, I don't like to think in terms of flaws, because truthfully, no language is perfect. No language gets everything right. You have to give things up here and there. I mean, I'll put it this way. I found very few problems that are right for the .NET ecosystem where I haven't found the F# language gives me a tool to solve it. The possible exception to that might be GUI work, but the only real sort of flaw or limiting factor there is tooling for auto-generation, which is not really, in my mind, a linguistic, and that's not part of the language. That's the associated tooling, and that's something that most languages, given enough time and resources, develop appropriate support for. So that might be one area where I choose not to use F#. I might make the GUI layer of a web application or a WPF application in C# or in VB.NET, but that's more a tooling thing than a language. Yeah.
One thing I keep noticing in these demos, but haven't had much experience with F# myself, is you have to do these conversions when you want to go from delegate to first class function, or from link IEnumerable to F# sequence. Like, is that really, like, that seems like it'd be a pain point. Like, that'd be, from a naive point of view,
the delegate to F# function, F# function is a delegate thing, is not, it is a bit of a pain point, truthfully, but it's one where it's, for example, it's like escaping strings. When you have to escape things in strings, it's kind of ugly, it's not the greatest thing ever. It'd be great if the compiler automatically knew that I want this to be a URL, I don't want it escaping my backslashes, but you've got to help it out a little bit sometimes. But at the end of the day, it doesn't really add up to much. As far as seek to enumerable, I'm not sure what you're talking about there, because seek is an alias for IEnumerable.
Okay.
So,
because there's all these different, like, seek.iter instead of...
Yeah, that's something that can be, and that may be something, I don't know about a flaw, but definitely something that I would say certainly can be a trip up, is there is some nomenclature differences where things wind up being the same thing or wind up being similar, but that's not necessarily totally obvious. But again, that's one of the things that becomes obvious after something you only need to learn once, and it's a quick thing. And then,
is there a reason why the compiler couldn't convert to delegates to first class functions?
I'm sure there's an excellent reason. Unfortunately, I'm not that comfortable with the internals of the compiler to know that. But I mean, we certainly have speakers here, have had, and have speakers here who have that level of familiarity to be able to answer that. Just, unfortunately, I haven't looked at it at that level. Anybody else? Yeah.
The nyc extension to F#, there's no shortcomings to it. It's the full-blown thing, right?
It's, to the best of my knowledge, supports the full range of features that nyc as a library provides. I've tested it fairly extensively on Windows XP and Windows 7. Is it possible that there's some obscurities using native code? So is it possible that you may need to recompile, make sure you have the appropriate native binary or something? Possibly. I haven't run into any issues with it. The company I work at is using it fairly heavily for a lot of things. So it's been in development for a while.
How do you use this? With nyc in general, how long have you been using it?
nyc I've been using for a little over a year now. We first looked at it because the hedge fund I worked for, we needed to do a lot of high frequency and more important, reliable internal data processing and data shuttling between different endpoints. So we started looking at it about a year ago. We liked it. At the time, there was a very, very raw C# binding for it that somebody else in the open source community had done. It really wasn't good enough, so we wanted to have it write our own. At this point, that's what this has evolved into, and it's worked quite nicely for us. So, particularly one of the things we found, even as that other C# binding has continued to grow and mature, I don't pay a lot of attention to it, but I do every so often check up on it, given I'm in competition, so to speak. And one of the things I did notice about it, that it still wouldn't be right for our uses, is it really isn't F# friendly. And that's one thing that I have found in .NET, is that it's much easier to make an F# library callable and usable and solid and friendly and great from F#, and just as fun and great and useful from other languages. but not the other way around. Trying to make a C# library feel, idiomatically F# is a lot more, it just doesn't happen as easily. So, but I mean, if you want to see, for instance, an example of this actual library being used from, other languages, it's a shame one of the other demo that I didn't get to show actually split a bunch of things out and featured the split test distribution amongst the C# library, or C# application, the VB.NET application, an F# application, and 2 C applications compiled for the Macintosh. So you can see, this isn't really magical code here. It looks and reads just like any other C# code. Should be pretty relatively straightforward to people what's going on here. And again, it looks very different from the F# code, but that's one of the things I like about it. You can make the language really go the distance for you. Because again, taking care of the consumers of your library as a library author is yet another problem and requires a certain level of abstraction. And making your consumers conform to a particular idiomatic language model that is not their normal mental model in their language, to me, is not addressing that problem at the right level. So, anyone else? Yeah.
I realize it's a general purpose language, but are there any, where would you say its real strength is? What kind of problems does it really fit the best?
I'm kind of a bad person to ask this question too, because I get asked this frequently, and my answer is, unless I'm doing something very, very GUI intensive, where I need the lots of auto-generated tooling to save time on stuff, or unless I've got an existing library where they've made explicit assumptions about the way the C# compiler does things, outside of those two scenarios, I haven't found an instance where I wouldn't rather reach for F# in the context of the .NET ecosystem. But I'm a little biased, admittedly.
But is there any area where it's clearly superior, where
Yes.
everybody would agree with?
Yes, I would say absolutely for concurrent programming, whether it's especially CPU-bound programming as opposed to, IO-bound and CPU-bound programming. Concurrent programming, it clearly excels. Anything that I would put in the realm of sort of linguistics and language-oriented programming, where you've got some very business-specific domain that you want to remodel in code. A fluent interface to me is not enough of a tool for doing that sort of thing. It gives you a lot of great tools for that, particularly with pattern matching, discriminated unions. We're using it at the hedge fund I work at. We're using it for a number of mathematical processing tasks. Certain algorithms. I mean, there's plenty of great stories. Members of in this room right now can talk to you about implementing very complex, algorithmically intense or mathematically sophisticated algorithms in F# where it's much easier. So I would say those are some sweet spots.
Would you say that F# is much more succinct than C#? Also, like Paul Graham talked about succinct coding.
Succinct.
So in the code, because I was reading some things that Microsoft had put up that certain groups like banks in London or something had adopted F# because it was much faster to code in and things like that.
I hesitate to say faster for things like this because, truthfully, it's about learning curve, and everyone learns at slightly different rates and in slightly different ways. I do find that line for line, in terms of what Don Simon likes to call the signal-to-noise ratio, you get more out of one line of F# code very often than one line of C# code because of things like type inference, because a lot of the boilerplate is reduced, because the compiler does a lot of convenient shortcuts for you, like you can declare the constructor, a basic constructor, in line with the actual declaration of the type, thereby saving you the extra code needed for a superfluous default constructor, things like that. But that's more economy of code, that's less, I wouldn't say faster, because again, faster to me is a learning thing. I have a friend of mine who's only does C and C++ programming, and his argument, and I think this is a valid argument, is that once you're used to reading a language, that language makes sense to you. So I tend not to look at speed of adoption in that regard. I will say though that one of the interesting things, just plugging ZMQ for a minute, the low ceremony aspect of it. I put together that chat sample. It took me maybe a half hour to cobble together, maybe less, and that had partially to do with being comfortable with F# giving me a quick and dirty environment via FSI. A lot of that also being right tool for the job. You've got a low ceremony distributed communication library. You can use it quickly and easily, as opposed to WSDL, I've got to generate a proxy. Oh crap, I didn't set the visibility correctly. I've got to make sure I have the right attributes so that my struct gets marshaled, yada yada. So I mean, it's, yeah, you know, right tool for the task. Yeah.
Can you or somebody just give a little hint about what's nice coding mathematics in it?
Okay, well, for instance, a coworker of mine, I'm not sure how familiar you are with financial mathematics, but the coworker of mine wrote a very, very succinct, very, very declaratively easy to read, straightforward, performant implementation of the Black-Scholes basic pricing algorithm in F#, and it was many, many, many lines of code, less than the equivalent, the older C# version that we had been using. It also was a lot easier for our non-technical, our quants and our other business folk to read. So, and that's one sort of very general mathematical example. I don't know that I can go into two more without running the risk of my company's legal department coming after me. Anything else? I think at this point, I'm going to turn it over to Steve. Get ready for, I'm sure it'll be an awesome presentation.
Let's give Paul a hand. That was great.